Throughout our history, we have managed to stay a leader in the technology necessary to design and manufacture components for the automotive aftermarket industry. We are proud of our record in supplying this market and the mechanic in particular with quality parts, components, and materials necessary to stay proficient and profitable in his workplace. As you well know, it is not an easy task to stay current with the latest changes in automotive technology. I'm sure you're very much aware of the information explosion. In the middle 60s, the mechanic could get by reading 5,000 or 6,000 pages of new text every year and still remain proficient. Today, the very same mechanic may have to master over 500,000 pages of text. Astounding! But by using the same technology that made these changes in the automotive industry possible, electronics and computers, we can also help minimize the effects of the information explosion.
Hello. Our discussion during this program is about wiring systems. Sound dull and boring? Hang on. Wiring and wiring systems, as you presently understand them, have actually changed, and you probably didn't even notice or care. But you should. By the middle 90s, the entire automotive wiring system will be unlike anything you've ever seen. Stay with us, and we will prepare you to understand how the systems are changing. During the process, we will show you how other new technologies have entered the automobile, and we will show you how the automobile computer control systems communicate, how sensors communicate with computers, and how computers communicate among themselves. Our goal during this program will be to supply you with the information to understand one of the newest concepts being used in today's vehicle, multiplexing.
Multiplexing, you will see, is the elimination of hard wiring, copper, presently used in all vehicles. The concept by which multiplexing functions is not new. It's actually the technology which allows many hundreds of telephone conversations to be carried over a single wire instead of over hundreds of wires. The automotive community has stated that by the mid to late 1990s, all vehicles will be using multiplexing extensively. Smart circuits are already being used to control lights, motors, and many other devices. Switching these devices by mechanical relays and contact switches will soon be eliminated. To gain experience in utilizing and installing multiplexing systems, the automotive manufacturers have started installing simple multiplex subsystems in the 1988 and 1989 vehicles. Let's begin our study with an explanation of a phrase we just used, smart circuits. SMART describes a group of solid-state or electronic components which contain the ability to process signals and control power within a single electronic component, like this Hall effect circuit. All electronic circuits or systems can be split up into three primary functions. Actually, you already are familiar with them. First, sensing devices. These include contact switches, pressure sensors, photodiodes, thermistors, etc. A second set of devices control power, switching transistors, integrated electronic circuits, solenoids, and electro-optical devices, etc. The third set of components processes signals. These you would refer to as computers, microprocessors, logic devices, amplifiers, etc. By definition, smart devices combine any two of these sets of components into one solid-state component. Smart power, smart sense, smart control. Like this memory seat control. It remembers two different preset seating preferences. The Hall effect circuit is another smart circuit. It is an amplifier, logic device, power driver, and a self-protecting circuit within a single device. Smart components are also used in quad drivers. You may have heard of the phrase, this component controls the power to the fuel injectors. They are presently part of what we call the computer, a general catch-all category. The introduction of multiplexing on the 1988 Chrysler, New Yorker, and Dodge Dynasty was just a start in using this new smart technology to eliminate the use of hardwired circuits. The integration of multiplexing on these vehicles allowed for the transfer of massive amounts of data between 4 or 5 separate computers and one central processor, the body control computer. Prior internal vehicle communication between the multiple computers had not been necessary to the extent that it was on this automobile. Previously, hooking one computer to the next or one component to the next meant merely adding more wiring. But with the addition of many new sophisticated components on this vehicle and the fact that it was a new design, it allowed Chrysler Corporation the flexibility to make a major leap forward into the wiring systems of the future. You should realize that this vehicle has ABS or anti-lock, onboard trip computers, overhead display consoles, an onboard self-test system that checks fluid levels and displays readings on a control panel, rolling door locks, automatic level suspension system, one of the first 4-speed computer-controlled automatic transmissions, and even memory control seats. During the process of adding all of these creature comforts and 5 onboard computer systems, the Dynasty and New Yorker managed to eliminate 80 hardwired circuits. Many needed 2, 3, or 4 wires running over the entire automobile to connect the various devices. The elimination of 80 hardwired circuits by using multiplexing was a major step forward in reducing weight and adding reliability. Let's back up and take a closer look at what multiplexing is, and then we will move into its application on Chrysler and those 89 General Motors vehicles that have multiplex steering wheel control SWC assemblies. In basic form, you could draw an analogy between multiplexing and a boat riding on water. The current in the water carries the boat downstream. The boat is the message, and the water is the communications link or bus to transport the message. In multiplexing, an electrical signal is placed on a wire or conductor. Riding in that signal is a message. The message is placed on the wire by a transponder or a transmitter. When it reaches its destination, it is taken off the wire to perform work. This is accomplished by a responder or receiver. Multiplexing has taken place. So what then is multiplexing? As far as we are concerned, multiplexing is the method by which computers or smart components can transmit information which we will refer to as data over a conductor or pair of conductors. When we refer to data, we are referring to the signals or information that certain sensors or computers find necessary to send between each other and the other various components in order to perform work. The data is in the form of voltage, the language of computers or microprocessors. A voltage, then, is made available over the multiplex circuit. You might be familiar with the words digital signal and analog signal. An analog signal is a constantly varying signal like a sine wave. It is varying because at any point on the analog signal, a voltage is present. The voltage rises above or below zero, both positive and negative. But though continuously changing, it changes only over a certain range. Now, a digital signal can be referred to as a square wave. These signals can vary, but not continuously. They are a distinct voltage or a pulse. This is actually the form of the data voltage on a multiplex circuit. The presence of a voltage pulse will be a yes, and the absence of voltage will be a no. You should understand that the pulse could be 1 volt and 2 volts, or any change in voltage. These digital signals are those which a computer uses to communicate. The communication data is sent in binary code by transmitting a series of zeros and ones, or yeses and nos, using voltage pulses. Any 2 microprocessors can communicate and or make decisions based on their programs. By stringing these sets of voltages, zeros and ones, we form the binary data message. A smart chip can also count binary code and do work. It would be pre-programmed, that is, given a series of instructions. If the binary message matched, like a key in a door, the smart component would do a performed task, like a switch turn on and off. The binary code is transmitted between components over data links or buses, data highways. In the Chrysler vehicles, the multiplexing system is referred to as the C2D, Chrysler Collision Detection Data Network. This refers to the collision of data, not the vehicle. Data is transmitted over a duplexed serial data bus, actually 2 wires known as a twisted pair, MX1, and MX2. The Chrysler system of multiplexing only carries the message. It does not actually carry the base current that a hardwired circuit would. The Chrysler multiplexing circuit was designed to allow communication between the body computer, the SMEC controller, the engine node, lamp analog module, and Electronic Vehicle Information Center, EVIC. The information is transferred to and from these computers. The information travels in both directions, so it is said to be duplexed, two-way multiple signal binary code communications, multiplexing. Let's look deeper into multiplexing components and how they work. We have already discussed that digital circuits transmit and/or respond to voltage pulses, and that the digital circuit responds to the signals of two levels. To perform this function, a multiplexing circuit is comprised of a group of some very simple solid-state building blocks or components which we will call gates. These enable it to accept or deny binary code impulses. Gates are really electronically sensitive switches. Like mechanical switches, they have two positions, opened and closed, or on and off. We'll demonstrate three simple gates and explain the terms, and then build a multiplexed circuit. We will use a battery, a light bulb, and a switch in a circuit. The first type of digital circuit or gated circuit can be illustrated with two normally open switches in series. Add a battery and a light bulb. Obviously, the only time that the bulb will light is if both switches are closed. This is called an AND gate. If we put all of the possible combinations for the two switches into a table, which we will call a truth table, you have four possible combinations, but only one of them will allow the lamp to light. That is when both the switches are closed. The second type of electronic gate is called an OR gate. Install two normally open switches in parallel. A new set of possible combinations. There are three circumstances under which the lamp will light, and only one under which it will not. A third type of gate circuit is called a NOT gate. In this case, it is a simple series circuit. We have designed it with a single normally closed switch instead of an open switch. Therefore, the light bulb is always lit. Obviously, there are two possible combinations for our truth table. In computer language, this NOT gate is actually an inverter or a reverser from the normal flow of electrons. Now, another look at the truth table, substituting binary code 1 for the on condition and 0 for the off condition of our gated switches. From this table, you can see where the binary code system of numbers comes from. Binary acts as if it were a key. When the right code is transmitted, it travels through the switch or gate and allows the circuit to do the work. If the wrong code is sent, nothing will happen. The electronic gates are building blocks of some extremely complicated integrated circuits, multiplexers, demultiplexers, touch switches, flashers, etc. Let's apply the concepts. Here's a component that we all take for granted, a simple directional signal switch. The directional signal switch does a number of things. In its simplest form, power is applied to the signal switch through a flasher assembly to the steering column assembly. As the switch is actuated to signal a turn, power travels through the switch contacts and out to a dash indicator light. Current also travels through individual wires to the left front and left rear signal lights. As current flows through the bulbs to ground, the flasher opens and closes to flash the bulbs. Sound simple enough? Or is it? What happens when the driver wants to stop the vehicle and turn? This assembly is actually very complicated, and hundreds of feet of wire may be needed to connect and operate the assembly. Let's substitute the multiplexing concept and replace the mechanical switch assembly in the directional circuit. This is what it might look like. The movement of the directional stalk sends a trigger signal to the multiplexer. The multiplexer output, binary code, travels on the X and Y wires. Instantaneously, it is received by the demultiplexers, or smart chips, at each location in the automobile. If the correct binary key is received, the appropriate lamp will light. In 1989, General Motors integrated multiplexing into the steering column controls on this Pontiac Bonneville and its Oldsmobile counterpart with the SWC steering wheel control. In this system, the control panel enables the driver to remotely control the heating and air conditioning system, including changing the temperature, blower speed, mode, etc. Also, it controls the radio, changing station, balance, volume, etc. The system functions by substituting a traditional multi-contact turn signal assembly for one that integrates photo-optics, infrared photo-optical emitter-receiver devices. The photo-optical units are arranged in such a way that by pressing the buttons on the steering wheel, an impulse is directed through 3 optical emitter-receiver units, none of which are ever out of sight of the other. The photo-optical data is converted in the steering wheel to an electrical pulse that is sent to the transponder or multiplexer at the base of the steering column. It sends binary code on the E&C bus for either the radio or the air conditioning systems to utilize. The system is capable of two-way communication, that is, to and from the radio or ATC units. Also, access to the information for diagnostics is available on the ALCL plug you are already familiar with. The General Motors E&C bus operates at battery voltage. In fact, if you input the system on an oscilloscope, you can see the code being sent. Consider the amount of data that is being transmitted whenever a button is pressed. For example, the radio seek mode. Code must be transmitted to the radio and back from the radio at each station frequency to check for signal presence, stop and/or continue looking for a station that is of correct intensity, and stop again until the operator stops the search. We will not go into detail on the diagnostics of the steering wheel control system, but it is sufficient to say that if the controls on the steering column do not operate, but the radio and heater controls are okay, the transponder or the switch assembly is at fault. GM makes a standalone breakout box that can be used in conjunction with a digital volt-ohm meter and/or a Tech 1 to troubleshoot the system. A second example of a multiplex circuit is used by Chrysler Corporation. In a hardwired, non-multiplex system, it would require 3 standalone circuits each, to and from each of the various computer modules, to communicate or transfer information about just the vehicle's speed and distance. The speed and distance information is needed by the SMEC computer for electronic fuel injection system function to adjust the idle speed motor, control the radiator fan, etc. It is needed by the EVIC computer to calculate trip fuel consumption. The body control computer needs the information to control the automatic door locking system, to display messages which require knowledge about the vehicle speed and distance, including door ajar signals, instrument panel information, interior lighting, etc. By multiplexing this vehicle, 80 hardwired circuits encompassing hundreds and hundreds of feet of wire are eliminated. A closer look at the Chrysler system shows that rather than hooking the speed distance sensor up to all 3 modules, it is instead only connected to the SMEC controller. After the SMEC controller receives the information, it is multiplexed instantly and sent over the twisted wire pair to be shared with the other computers. The twisted pair connects all the computer modules, allowing the information to be utilized simultaneously throughout the vehicle. This system uses no photo optics to transmit data. Chrysler states that the design was chosen to minimize the effects of EMI, electrical magnetic interference. The twisted pair operate at 0 to 2 1/2 volts above ground, but neither wire is actually negative or positive in respect to normal body ground. The pulse or code is merely 2 1/2 volts more positive than the other wire. When current flows, it represents a logic 0, no voltage difference. The opposite circuit, or no current flow, on the bus gives 2 1/2 volts potential difference. It results in a code 1. The binary code for a 21 would be 101010. No current flow, flow, no, no, no. The binary code for a 23 would be illustrated as 1 0 1 1 1, Remember, Chrysler's communication link is a serial data link. It does not transmit parallel. Each computer in the system can transmit and receive codes, but only one code at a time can be transmitted. But since the message's duration can range from 0.083 seconds to 1.6 seconds, time isn't a concern. In this circuit, if multiple messages need to be sent simultaneously, the body control computer acts as a traffic cop and prioritizes them. A closer look at this Dodge Dynasty and its multiplexing circuit shows that the body control computer is mounted in the right kick panel. The multiplexed twisted wire pair is part of the 25-way connector harness. Bus minus and bus plus are connected to the SMEC controller and also to the diagnostic connector. The diagnostics connector is located underneath the dash to the right of the steering column. You should realize that Chrysler uses two different systems, a basic and a premium body control circuit. Both systems perform a series of functions and communicate between the SMEC controller for much of this information. If the SMEC controller senses an engine computer malfunction or an engine control component malfunction, the body computer signals a check engine indicator light and also sounds a chime. The chime also sounds for 6 seconds if the driver's seat belt buckle is not connected when the engine is started, and chimes if a door is left ajar and the vehicle speed exceeds 2½ miles per hour. With an oscilloscope connected to the bus minus and bus plus wires, watch the computers communicate with each other. The premium body control computer system has 5 separate computer modules. They all communicate with each other over the twisted multiplexed data link. The data highway travels from the body control computer to the SMEC controller, then to the EVIC, Electronic Vehicle Information Center, the lamp outage module, and the engine node system. In addition to the basic system, numerous information has been added. A differential switch which controls the anti-lock system warning light, low windshield washer fluid, low fuel, low oil, headlights on, headlight dimmer, backup indicators, and other various light monitors and fluid level indicators. Diagnostics on the Chrysler system is not radically different than the General Motors system. Utilizing the Chrysler DRB2 scan tool connected to the various diagnostic connectors will enable the mechanic to troubleshoot any of the problem systems. You should understand that if the vehicle's systems have multiplexing circuits, any number of problems can be associated with it. Things like interior lights not functioning properly, warning lights not illuminating when they should be, or illuminating when they shouldn't be, intermittent windshield wipers not functioning properly, and many other possibilities, including the possibility that the vehicle may not even run or start if a problem exists. Primary problems with the data highway show up normally in 3 forms: open or poor connections in the data highway, a bad computer power supply, and the third type of problem takes place with a major failure of the bus circuit, shorts to ground, shorts to the battery, the wires shorted together. These could cause anything from the engine not to start to conceivably a blank message on the EVIC control panel. Sound complicated? Possibly, but this is just the beginning of the utilization of this new technology. In the not-too-distant future, the entire automobile will communicate between smart circuits. In the near future, the vehicle as we know it today, where components are connected by hard wires, will cease to exist. Electronic communication via data links with minimal wiring will become the rule instead of the exception.
In future programs, we will continue to discuss multiplexing as well as hardwired circuits when the subject of body control computers is covered. During the body control computer program, we will study General Motors, Ford, and Chrysler diagnostics function of various systems. I would like to take this opportunity on behalf of Standard Motor Products and its corporate training department to thank you for supporting our product lines.